rate of change H. Connected rate of change, right? So meaning they are connected. Connected rate of change. Connected rate of change. Just to recap what we did the last week is something like also what we call connected derivatives. Connected derivatives. Okay, where last week or last Friday I talked about how we can have, instead of dy dx, we can have dy dt. Also the last time now, the last week, remember this is what I started with. Then doing that, if I have a graph, then this gradient function or the change, basically the gradient is dy over dx. Okay, so from there, then I went on to this part. So I say that, instead of finding dy dx, where the gradient is a change in y over the change in x, that's probably get attention for a while. Okay? Very quickly. So then I tell you that from y to x, I can also have maybe p and s. Okay, who takes physics? Quick show of hands. Okay, quick show of hands. Yeah, so we take physics, right? So let's say S stands for displacement, right? Then T stands for time, right? Then we can also have the gradient, which is the change in displacement over the change in time, right? Which is also ds dt. So the gradient can also be seen as ds dt, right? Instead of dy over dx, I can say ds over dt. Okay? So if I look at this, then what's the gradient of a displacement time graph? Velocity. So actually, velocity is ds dt. Okay, no? So if I ask you, if you know that velocity is ds dt, then what is dv dt equals to? Anyone? Acceleration. Fun, right? Oh. So you see, that kinematics is very easy, right? Let's see, what did I say? What's acceleration? You stop talking to home and listen to me, okay? You're so dating in my class. Okay, whether I say over already, okay, so listen. Okay, can, so listen. Okay, so with that, right? So I have a lot of different derivatives, and how do I connect them together? So the connection, right, is where we talk about how we have three derivatives. Okay, so first, this chapter, you must be very comfortable that it's not just dy dx anymore. It's not just dy dx anymore. It can be dy dt. And the way we look at it is, if I have dy dt, is I differentiate my y with respect to, with respect to t. dy dt is I differentiate y with respect to t. So far, okay? So you see example, the dx dt, it is what? In English, I differentiate x with respect to t. Okay, ma? I can also say this is a rate of change of x. Okay, how fast x is changing with respect to time. So far, okay, so this portion here, we look at three derivatives. There are three derivatives that are connected. I was saying last week, of the three derivatives that are connected, one is usually given. So example, dx dt is given. One is usually the one that gets you the marks. Okay, so example, they tell you go and find dy dt. Last one is the one that's hiding. Okay, last one is the one that's hiding. So how do I see? I form the equation. Okay. This is the one I need to find. dx dt is here. So it must behave like a fraction. What do I need here? Let me ask. Who was here last week? Can you help me? What variable should be here? dy dx. So how do I know that it's dy dx? Because in a way, they cancel. It looks like fraction. they cancel. D1 dt is D1 dx over dx. So far okay? Can So then let me just go through question 2.3 again very quickly the last week. You can see in this example. Here in the whole essence of this chapter is to find three derivatives. Okay? This one is dx dt. X is increasing at a rate of 1/6 milli per second. Okay? That means they tell me that dx dt is 1/6. Okay? I'm supposed to find the rate at which y is increasing. Find dy dt. What am I given? I'm given y and find dy dx. So this is the brother that's hiding under the name. This is the one that is hiding. Okay, huh? So what do I do? Very simple. Find my dx dt. Find my dy dx. I can form the rate of change equation, which is very similar to change. Okay, so all these are just a recap of last week. Because I do acknowledge that this one, when you teach one time, people will be lost. So I teach second time, third time, fourth time. Okay, so okay, just allow me to teach you one more time. Then let's go to today. We are looking at 2.5 and 2.6. If you are fast, you can do the AFL. Okay? Can I? Okay. Let me look at 2.5. The one in water is the one in water. Is the one in water. This one. This is this. Is it okay? Can I? So based on this, right, this is the small triangle here. The big triangle, which is in blue, is 9/30. The big triangle, which is in blue, is 980. This is 9 cm over 30 cm. Okay, these are two similar triangles. Okay, so from here, I can say that 0.5 L over H is the same as 9/30. This times this, 15 L equals to 9H. L is 9H over 15, which is 3H over 5. Why do I go through all this hard work? It's because we need our B is like that. So why do we do that? Because currently B is 1/3 times base area times height. Can I do dVdH? Can I do dVdH here? If I have an L here, can I do dVdH? Cannot. Can I do dVdH? Cannot. Because I have an L. But if I do this, if I use this to sub, 1/3, L is 3H over 5 square times H. This is 1/3 times 9/25. 9H square over 25 times H. Cancel 3H cubed over 25. Now, instead of this, my volume looks like that. Can I do dVdH? Yes, I can do dVdH. Okay, can I? So there are a lot of difficult parts. Number one, of course, is forming dH dt equals to dVdH times dH dt. This is one. Okay. Number two is the difficulty expressing B in terms of H. Okay, this is the part where you use similar triangles. Okay. Yeah. Because what? Oh, sorry, I used the wrong one. Thank you. So so by right is supposed to look like that, right? dH over dV times dV over dt, right? I can write this one is divided by dV over dV. Anyone still lost? Still lost? This one. Use X and Y. That's what we use. Okay. Okay, what do they want is they want dy dt. They want dy. What's dy dt? Yes, it's not fast. When the rope is shortened, it's unshortened this rope. It may not be what dy dt. Yes, it is negative 0.75. Different from dy dt. If I shorten the rope, right? If I shorten the rope, if I throw and I shorten, let's say I do fishing, right? I drag out. It doesn't mean the fish will come out of the water straight away. The water can also be swimming, right? So if I'm fishing, right? Imagine if I fish, the fishing line is shortening, right? But the fish is still in the water. It doesn't mean that the moment I shorten the fish won't come out of the knee, like at an angle of 60 degrees. There will be a lot of water before it comes out. So along the so you'll see that this rope is shortening at the speed. This boat is coming to you also at the speed. Two different speeds. The rope shortening is negative 0.75. The boat moving fast, that's dy.
Basically, do you know dV? The one
The first speed is for the rope. The second speed is for the boat.
And the link with the time.
Correct. But when I'm moving, right,
you need to find dV. Yeah, then you find that and then you go.
so it's just like, for example, right, if I blow a bubble, right, bubble goes up, right, you see the bubble is moving up, right now. Right. Along the x-axis is having displacement, right? So there's a dx dt as well. Along the y-axis, there's also movement. So it's dy dt. So I'm measuring the two displacements. So depends on your direction of answer. When you go, when you talk about speed, for example, explain direction. We can do this all velocity or direction. Okay, so imagine imagine you're the one here, right? You pull the boat, right? When you pull the boat, right, the boat is not going to go out of the water towards you, right? So, but when this rope is shortening, right? This rope will shorten at a certain speed. For example, maybe 1 meter per second, 1 meter per second. But at the same time, as you shorten this boat will slowly come towards you. So here in this distance, there's another speed. the 2. So here is 1, here is 1. And I would say rate is a rate of change. There's a rate of change for x. There's a rate of change for y. Also, does that separate? Cannot. So how are these two connected? Actually, y against. You can also do y over dx. You can also do dx. So here you see they are telling you right.
No, it's correct.
Yes.
Then you
Yeah.
use it.
This one. The rope is very shorter at the rate of 0.75. Negative 0.75. Okay. Now, they ask you how fast is the boat moving when the boat is how fast is this boat moving? How fast is this one? That means what they want is they want distance ratio. Okay.
Oh, you already did
Okay,
it.
so they want this is the one that
It's
gets you
supposed to be 5 divided by.
short.